for giving me this opportunity. Oh, sorry. Good afternoon, ladies and gentlemen. My name is Rajit. I work in a company called GreyOrange. We are into warehouse automation. We are a global company, and we are located in various locations. And our customers include Flipkart, Myntra, Jabong, and maybe recently Walmart. Let us move forward. I think everybody of you may have ordered something online ever in your life. So do you know how things come to you when you order something online? Beyond the scene, it is our GTP system which ensures that you get your orders on time. So GTP stands for Goods to Person System, and it includes butlers. They are actually the robots. Also includes mobile storage units. Butlers carry them to stations. These stations are called pick-put stations, where people consolidate your order, pack them, and then it is shipped. So these all systems work in a intelligent software-based system. So there are other things also called charging system. So when these butlers get discharged, they automatically go to their charging station, get charged, and then again come to work. So these are like the excess human effort which nobody would like to do. We get it done by these butlers. So before proceeding, let us have how all these things happen. Can I have the volume?
Changing. With various online and offline channels of sales and services like same-day delivery or store pickups, customer preferences have evolved, forcing companies to reduce the order-to-delivery time. The sheer volume and mix of orders means that warehouses across the world are under increasing pressure to deliver in the shortest possible time. Here, all traditional rigid warehouse automation fails to meet business needs. A flexible automation is the only viable solution for warehouses to gain a competitive advantage. Meet the GreyOrange Butler system, an intelligent goods-to-person order fulfillment system that consists of butler, pick-put stations, mobile storage units or racks, and smart charging stations. The Butler robots come in two variants, and its primary job is to bring racks to the operator. Butler M, which has a payload capacity of 500 kilos, and the larger Butler XL with a payload capacity of 1600 kilos. The mobile storage units come in different sizes that can handle a variety of inventory, right from eaches, cases, sacks, pallets, to barrel drums. Even if inventory characteristics change with time, MSUs can be reconfigured to meet changing business needs. The multi-purpose pick and put station is an interface between the warehouse and the Butler system. It is designed to support custom business needs and enable high-speed, error-free pick-put and audit operations. This allows faster fulfillment of up to 48 orders simultaneously. All this is powered by a state-of-the-art, decision science-driven software platform, the Grey Matter, that intelligently manages executors and seamlessly integrates with every WMS and ERP system, and also has a core operating system that supports multiple business workflows that comes with pre-configured intelligence for different industries. The latest addition to the GreyOrange product family is the PickPal autonomous picking system, a robotic picking system that works hand in hand with the Butler system and the operator and picks items directly from the storage units to boxes or bags that are ready for shipping. All this ensures faster and accurate order fulfillment, effective space utilization, growth enablement, efficient inventory management, and 24/7 operations. Making the future of warehouse automation a reality.
So when I say 48-hour orders simultaneously, there is a term called throughput, which is very important. So throughput is a number of orders processed per unit time. So it is same like in a automobile industry, how many cars you manufacture in a day, something like that. So the throughput mainly depends upon a very major component of a warehouse called operator stations. So this is actually a operator station. We call it pick put station. So here orders are consolidated, and operator, this is a human operated zone. Operator works here to pick the order from that storage unit called mobile storage unit, and consolidate the order to process it further for packing, etc. So the design of this pick put station is very important. Just imagine how much a 10 mm excess length of any shelf can affect. Your online order can delay it by 1 full day, just with excess 10 mm length. So the designing of the shelves, the placement of these touch buttons, there are many components in this pick put station, like a touch screen called AIO, a projector focusing on the MSU, a hand scanner, different locations of touch screens at different shelves. So all these things contribute and aid a operator for a faster pick and put operation. So this designing is a complex system because it varies from customer to customer. We'll see how and what are the factors on which all these things depend upon. A very important factor is the human ergonomic. So in GreyOrange, we have a dedicated industrial designing team which works parallelly with mechanical design engineering team to understand various requirements of this pick put station, and also we do study on various body postures and various locations of body postures to understand what is the best possibility for a pick put station. So we also have studied that what are the adverse effects, what happened in such kind of stations. So physical strain is a very important part in warehouses. You must have heard about that. And not just physical strain, it also affects the job satisfaction of any person who's working in such stations. So with just a good design, you can ensure not only betterment in physical strain, but also better job satisfaction of operators in such stations. So there are many factors which drive this PPS design. A PPS design for an Asian customer having the same requirement of a US customer is different, because the body structure of the European customer or maybe US customer is different. Similarly, if the operator is female, it is a PPS design would be different for that is a design for a male operator. So our ergonomic study helped us a lot to understand how to design this PPS and for whom what should be the exact design for the PPS. Designing this PPS solution for our customer was never easy because it was very iterative. So our technical solutions team do a close to and fro discussion with the customer to understand their need, who will be the operator, what will be the items they will be using as their SKUs. So this helped us to understand their requirements, and based on that, these PPSs are built. So very frequently their requirement change, maybe the operator gender may change or anything may change. So this always became an iterative process. Somewhere we felt that we need a very smart tool, some tool that can help us to change the design whenever we need, just in front of customer. Some tool which has capability to demonstrate a real 3D PPS in front of customer. So we dug deeper. When we dug deeper into the problem, we found that the production team, the SCM team, BOM segregation, everything was like by the old process of CAD design and everything. So what we did, we thought to make a tool called PPS configurator to solve this process. This task was taken by the mechanical engineering team in GreyOrange, and I will show you how this thing happens. So initially we detailed about our offerings, what we do to our customer, what are the range of offerings we give to our customer, which helps us to kickstart this project. So we made a technical specification sheet for and listed down all the parameters which will be driving the features of a pick put station. So these are like the operator gender, all the distances, what are important, what are the sizes of shelf, etc. After that, we'd need some tool which can help us to do a rule-based modeling, something in which we can order something and it will give a return 3D CAD just on the go. So we used Inventor for that. These are actually the iLogic parameters. These are the rules which drive the parameters. So we made these rules in Inventor. After that, we made code. So these codes are actually driving those parameters to design a 3D model. So we need, these are actually the buttons which we click, or maybe the values which we enter in these boxes to make any 3D design. So whenever we change any parameter, we get a new design of PPS. We'll see how all these things happen. So this is the interface in Inventor. I will explain you how all this thing happen. So these are all the peripherals which we use in a PPS station. The scanner, this is a single column, single row basic model of PPS which anybody can open when he opens PPS configurator, GreyOrange PPS configurator. So you can see the model tree, simple folded model tree. So to open the configurator, we have to go to maybe manage. There we open iLogic. So this gives us an interface of the tools which we use to model this PPS station. So we have different options in this iLogic browser. These tools we will tweak, and we'll see how the PPS design changes when we play with them. Video got paused. No. So these are the rules. So actually each rule has its own specific task. We segregated it so that if we need to change it in future, we can change it. So segregation is very important while writing any code in Inventor. So currently we are having one column, one row system. This is a shelf with one partition. This is a basic model. So let us get into the code, how these codes are written. Okay. So this is a normal code which drives the height of AUIN scanner. And as you can see, this is written in camel casing. You can easily understand operator gender. So we have written the code based on the assembly parameters, and these parameters are guided by the code which is written here. So whenever I click a male operator, it directly changes the height of AUIN scanner as per the specifications we have finalized during our initial stages. So these are all the parameters which drive the 3D model directly inside this PPS configurator. So we'll see another parameter, another rule. So you can see how we have segregated all these things. This is very important because maybe in future you would need to tweak something if your offerings changes. So this rule drives the length of shelf. Your rule can also like go for 3-4 pages. So segregation is very important. The name of parameters are also very important. Okay. So we'll start with, I think, a UI. The first UI will be, these are all the UIs: partition planner, width setting tool, PPS sizing tool. So we'll play with them. We'll see how you can directly change them. So you can see the BOM is also there, which will change after we will do all the changes in the PPS design at the end. So let us see what is the current BOM. So as per the design, the BOM is also like very important for us. So we'll see how this will change, the quantities will change when we will tweak the parameters. So I think the starting will be structure builder. Okay, now close this. Structure builder. Yes. So this UI is used to change the number of columns and partitions, number of rows and columns of a PPS system. So currently it is 1. So if I want to change it, maybe 4, it directly enters 3 more columns on the fly, adjusting everything. If you can see, the last control panel has also moved to the end. So this is all driven by the rules which we have created inside this tool. So now we have total 4 columns. This control panel has also adjusted. And now we can also change the number of rows. Currently it is 1, you'll see. So we have only options which we provide to our customer are there in these options, so nobody can even make any mistake. So these are all rule-based inputs. So I'm changing it from 1 to 3. So in this process, we are entering total 3 number of rows in each column. So all these things which you can see is an automatic process. With just a click of button, we can change various sizes and heights of various shelves, which is also given there. We can use a slider also. We have option. We can enter directly on this. So maybe 1600. How much? Yes. So when we change the height, this is the top height. So when we change the top height, it increases the height of all the columns. Also, it keeps the projector at the same height, reducing its tower height. Now we are changing the first column's base height, bottom height. So you can see not only the height is reducing, also the partition heights is increasing, and the bottom partition height is reducing. So since this whole system is a rule-based model, we can play with it as per our need. So there is no chance of any mistake because this tool is fully tested, and all the parameters are rule-based parameters which you are driving from here by using these buttons. So now we have total 3 number of columns, 4 columns and 3 rows with just few clicks. This whole system is now a new system. So you can see that a column has 2 partitions inside it, and each partition has a center touch button inside it. We call it PPTL, pick put to light. So these buttons are used to count the item number. It also confirms that the order has been done. So these are actually the terms very much used in warehousing. Maybe you are not much aware for that, so I am explaining it. So now we are using this shelf depth slider to adjust the size of depth of shelf. So we have used this slider. It has reduced the size of depth. So depth is this distance which we have reduced. It also reduced the partition depth, everything, with just 1 click. It is currently 420. We can maybe change it again to show you. So from 420, we can change it to 600. So when we tweak it, you can see all the shelves will have an automated increase in height from 420 to 600. Also, you can see the slant height of projector which will increase directly. So this is all happening by the automation which is working behind. A full automatic tool to design such kind of stations. This is very important to design it very fast because you have to show this in front of customer. So you can see also this slant is also changed. The depth of the shelf has also changed for all the shelves. We have also option of geolocation and operator gender here. So if you change the geolocation, so the position of AIO and scanner will change. It will show this. So these are two options, a Asian customer and a European customer. So currently it has the Asian type of customer. So they are like, as per our studies, their height are a bit lesser than the European type of customer. So I'll demonstrate how if we'll change the height of this, the customer region, it will change the height of the AIO and scanner. So when we tweak the geolocation, it will tweak the height of AIO and scanner. Similarly, the male and female operator can also be tweaked. You have also option of both male and female operator. So in case of both male and female operator, the privileged is for female operator for lesser height, and for male operator, the bending of an operator has been taken care of. We have more options. We will see the different options of width sizing tool. So width sizing tool does what? This is very important, because this accurately places all the partitions in equal spaces and increases or decreases the width of any column. So currently it is 900. So we can tweak it, 800. So we can tweak it to any value, a new value. So there are two values, 800 and 842. 800 is actually the area which we are getting as our width, and C1 profile length is the profile length is of the original column. So this is important because the actual distance we get from the customer, that we have 3 totes which we have to enter in this area. So sum of all these things should be entered in the value which it is entering, and the exact length which we will get is a different value. So in column 2, it is again entering a length. So as you see, when we tweak the lengths, the different columns get expanded, keeping all the partitions and touch buttons at their exact position. So this is very important while designing such solutions just in front of customer. So we can tweak their values. We'll get all the things aligned as per their positions defined in the rules. So we have tweaked 2 different column widths, and I think we are done with this UI. The video has stopped, I think. Okay. I didn't click actually. So no problem. That was actually the ending part, so no problem. I can skip that. So what you have seen in this last video, I have briefed in a few minutes. Do you know what happened in between? So we changed around 400 parts in this video, and this was like a normal speed video. We haven't changed the speed of working. So we changed around 400 parts, introduced 150 hardware components on the fly. We changed around 1,500 constraints in few minutes, inclusion and deletion of constraints. It also saved 16 hours of design time. So in few minutes, we have done something which someone could have done in 16 hours. And also, it would also need 3 resources. One is maybe a senior design engineer to design this new system from 1 column to 4 column, 1 row to 3 row. A senior design engineer to review all the things have been done perfectly or not. And finally, a tech lead who can give a final sign off. So we have changed all these things, and we have reduced all these efforts in our process. So these are the stats and figures what we have achieved. We have achieved a significant reduction of time and effort. We got a 95% efficiency, and we have reduced the effort of our sales team. So this value is based on the customer projects, the studies we have made on the real-time projects with our customer. The solution time reduction is 98%, which is a big amount. So nobody has to go to and fro and do the designing part. And the tech team involvement, who was doing this not so interesting work, has fully been removed. Now we have 100% freed our tech team to design the PPS configurator design. So this is the automation we have done. In GreyOrange, we not just deliver warehouse automation or automation as our deliverable. We also try to do it in our work as a part of our culture. So this should be important. Thank you.